Okay, let's get to work on our second application. The first thing to do is open GNS3 and start all the routers. Make sure to have a connection from the hub to each router's Fast Ethernet 00 interface, and of course IP connectivity from the virtual machine to each router. So let's test the connectivity. 192.168.2.101. This is R1. Okay, it works. 102, 103, 104, and 105. Okay, great. Remember, if you made your connections according to the network diagram, loaded the configuration files I provided you with, and Fast Ethernet 00 is up on each router, but the pings from the virtual machine aren't working, then try to delete the cable between the virtual machine and the hub in GNS3 and add it again. This happens to me sometimes. I thought you should know too. Now the second thing you should do is create the files we need for this application and add some data to them as well. I have already created them, so let me show you. Cat ssh ip.txt. Okay, this is the IP file. SSH user pass, and finally SSH commands. Okay, nice. All files are in the same directory as the Python file holding the code for this application. Also, don't forget to enable SSH version 2 on each router using the command crypto key generate RSA and using 1024 bits for encryption. Now we're good to go. Let's see the code. First, as always, the import statements. Notice that I've imported several modules. Paramico is for SSH functionality. Threading is, of course, for threading. os.path is used to find and validate the existence of a file in the operating system. Subprocess will be used for pinging from within the Python code. Time will provide the sleep function for the SSH connection. Sys will be used for exiting the program in certain conditions. And finally, RE will be used to search for two strings in the router output, the username and password strings. Okay, enough about importing. According to the plan we made, now it's time to ask the user to input the file storing the IP addresses and check if every address in the file is valid or not. For this, I have defined the IP is valid function. Inside this function, I defined a variable named check and assign it the boolean value of false. Let's keep it for now. You'll see its use in a moment. Next, using the global keyword, I told Python that I'm going to create a variable named IPList, and I want that variable to be available outside the function, in the global namespace, not just in the local namespace, because we will use that variable in other functions too. You'll soon see what are we going to use this variable for. Next, inside the while true loop, we ask the user for a file name and extension in which to find the IP addresses to connect to. Of course, the row input function helps us again. I've also added some print statements with a lot of hash signs before and after row input, just to make the output prettier. After the user types in the file name, it's time to open the file for reading, making sure we read from the beginning of the file, and then use the readlines method to get a list where each element is a line in the file. In our case, each element will be an IP address from that file. This list is stored in the IPList variable that we declared as global earlier. Okay. Finally, we close the file to avoid any unexpected behavior and wrap this code into a try except block in order to cover the case in which we mistype the file name and Python doesn't find it. If this happens, Python will raise the IO error exception and print the message it finds under the except clause. So, the name of the file does not exist. Please check and try again. Next, inside the same while loop, we use the same piece of code we saw in the previous application for checking the validity of each IP address in the file. I have explained the algorithm behind this IP address checking when we discussed the subnet calculator, and that's why I'm not going to do it again here. So for each IP address in IPList, Python is going to split that address into octets and then analyze those octets. The if-else block here says if the IP address meets all these conditions, then the program should break out of this for loop, but if it doesn't, then it will continue to the next IP address using the continue statement right here. The new thing I've added is the check variable that we initialized with the value of false up here. I'm going to use this variable as a flag to signal some conditions. So if the IP address is valid, then the value of this flag turns to true. So check equals true. But if it isn't valid, then it stays false. Okay, simple enough. Now let's see how to use this flag outside the for loop, so after the IP address has been evaluated. We're going to use a new if-else block for this one over here. If the value for the check flag remains false, so if the IP address in the file is not valid, then the program will go back up to the while loop, right here, asking for the file name again, hoping you made the necessary corrections. Let's try this by replacing the IP addresses in the sship.txt file with a single invalid address. So let me get into the file, vim ssh_ip.txt. I for insert, let me delete all these addresses here. And let me type in 192.168.1 or 2.500. Let's save the file. And now let's run the application. So ssh_ip.txt. Okay, so as I said, we got the error message and we are redirected to the top of the while loop. So there was an invalid IP address, please check and try again. And now we are prompted to enter the file name again. Otherwise, if the IP addresses in the file are valid, then the check flag will be true and the elif clause will be executed, thus making the program break out of the while loop and move on to the rest of the code. So this break statement will be executed. This has been part 1 of this application. Let's see part 2. Meanwhile, you should enter the correct management IP addresses of the routers back into the ssh_ip.txt file.